So for today, we are doing 3 major tasks for those that missed today. One is we are going to be going in and using the online or in if you have it with you, your graphing calculator. So everybody right now, take out your graphing calculator if you have it with you. From what I've found, the vast majority of kids have that, and it will be useful on your next test, and it will be useful right now. There'll typically be at least 4 or 5 kids who need me to show them where the online graphing calculator is. Okay, so please raise your hand unless I get that lucky, which would be fantastic. So if you're at home and you don't have your graphing calculator, you go to the yellow folder on my site that's called the Welcome folder. All right, and inside the yellow folder, there's another yellow folder that says Graphing Calculator. Click here. And again, it'll pull up something that won't be clickable unless you have logged into single sign-on first and you're going through Safari to get your Schoology page. All right, so the yellow welcome folder, and then inside that is a yellow graphing calculator folder. Then you can just basically click start enough times, and then a little tiny icon at the top of your page appears that looks like a calculator. And then you click on that, and then poof, you have a calculator up on your screen. Okay, so I'm just going to verify that everybody's either got a calculator on their desk or the calculator up on their iPad. All my students either have a graphing calculator on their desk or they've got it up on their screen. All right, so the first thing we have to do is enter some data. We're going to learn about regression here for a few minutes, and then we're going to go outside and we're going to toss a ball in the air and take some data for your lab. Today it's still decent outside. Tomorrow and the next day it's going to be raining, and then you have Friday off and it's going to rain through the weekend and stuff. But main point is we really need to collect that data today for throwing the ball up for the tennis ball lab. And then the last thing we're going to do if we have the time is we're going to grade a worksheet that you did last night, which was called 5.1 to 5.4 quiz. So we'll grade that at the end of the hour if we have time. We still have the 10-step quiz out there, but we won't have time to do that today. I can guarantee that. All right. Now, all of you hit the button called Stat. It's kind of in the middle-ish. You'll find it. It's the only one. There's only one button that says Stat on it. Now, once you're in under Stat, you have 4 choices, or 3 at least across the top. One of them is Edit, and that's the one you default into. So choose Edit and hit Enter. And then you should see List 1, List 2, List 3. And if any of you have a bunch of stuff in those, use the DEL key to just delete out all the data that's already there. Most of you probably don't have anything on your list because you really don't use it that often. All right, I'd like you to have this up on your screen at this point. And this time, I want you to compare with the kid next to you just to make sure they're in, they've got the list up, and that they have an L1. Some people, their L1 has been deleted. All right, for today, you two are going to compare diagonally this way, and you're going to compare with Garrett behind you. And you show her that you got your list up. Compare with each other. DEL, delete, keep getting the DEL. Keep deleting out the data. So you have a nice blank screen. Show me. You guys got them up? No. I need to reset them.
Oh God. I was trying to
You can wipe your whole calculators. I don't care. Resets?
Oh,
yeah. Do you have data on here?
Yeah, I have
Resets. Okay, then your life's going to be really complicated because I can only get your L1 back by completely resetting your entire calculator. That's the way they were built. If you want to Google it and try to figure out a way to bring your L1 back without resetting your calculator,
Mine's fixed now.
there might be a way if you Google it.
You can reset randomly.
Yeah, but she doesn't want to reset her calculator because she has data in there. All right, because
My data's specific.
okay, good. We've got it so that almost everybody is set to go with an L1 and an L2. I'm going to pause for a second. Oh, now we need data to put in there. In the L1 list, that's where we kept track. This is finger length and height. and this is in centimeters, and this is in centimeters. And the first one is 7.5 goes with 189. Now you're typing this into your list, and I messed up one of my numbers, and it really messed up the whole thing. So be very careful as you put in your numbers. I am double checking mine because, again, there's a lot of data I had to put in there, and it'd be very easy to mess up just one thing. I would do the same when you're done with your list. Double check yourself. Otherwise, your data is going to be all different than your friends next door to you, and you'll be like, but why isn't mine the same as hers? Okay. There, I have double checked and I put in all my data correctly. Okay. I'm going to pause for a second here and let people get caught up. Okay, this next part, you've got your data in, and it's going to feel like you're going to leave it and it'll all disappear. But this is kind of like a Google Doc. You leave it and you come back to it, the data will still be there. So we're going to get out of that and hit stat again. Just hit stat. The data will disappear, but it stays in the memory. So hit the stat button again. Now what choices do you see? Well, edit again, but we just did that. So what's right next to edit? Calc. So under stat, you are now doing stat calc. So choose that by hitting enter on calculate. And now there are several choices. There's 1 var stats, there's 2 var stats, and if you go down a little further, you're going to see lin reg. Does anybody raise your hand if you see lin reg? Okay, good. Is it the 4th choice, I think? Yeah. Okay, good. Then you could either hit a 4 or you could arrow down to it and hit enter, but choose lin reg. What that stands for is linear regression. And I'll show you what it does in a second after you've pressed lin reg. Okay, so you're under lin reg. Now, vast majority of you are going to see 4 things. The first one has an L1 after it. The second one has, L1, Mr. Server. So most of you see L1 here and L2 here, and the next 2 are blank. Raise your hand if that's you. You see that. L1, L2, and then a bunch of things. Okay. Who doesn't see that? Yours just says lin reg on it. If it just says lin reg, you need to walk forward, and I'm going to show you what to do personally. If yours just says lin reg, walk up here. Bring yourself and your calculator up here, and I will show you what to do. For those at home, if you have one of the old calculators, it'll just say lin reg. And then you have to, after the AX plus B thing, you have to write, and I'm going to do it in red here, L1, but it's on the calculator. If you look above the 1 key, do you guys see above the 1 key that there's an L1 there? Okay, so then you get L1, then you say comma, which is above the 7 key. See where the comma is? We want L1, comma, L2, and then hit enter. Yep, comma's above the 7 key.
I only see U and an O right here. Oh, okay.
There you go. L1, comma, L2.
Like that.
Perfect, hit enter, and let's see what it looks like. And hit enter, that's good. Let's see what it looks like. Make sure yours looks like yours.
Exact same results.
You guys getting the same thing as each other?
Yeah.
Okay.
I fixed it. You just go to setup editor and then click it, and then it just resets.
That's a new thing. So
that
show me where
you
that was
have-
again.
It's just in the edit. And
Under stat,
and then edit.
edit.
And then
Setup
setup
editor.
editor. And then
Just hit enter.
and then
Dang, you're the first person after this is literally 10 years of doing this who's found that. Nice job. I'm impressed. Okay, I think you guys are good. Yours is, yep, they all, as long as you look the same as the other people. Okay, so unfortunately, there's two operating systems, and that's why I had to have kids come up here and show them how to do this, because they'll need to know it for their test. They have to type this right here. They have to type in L1, L2, and then with a comma in between and hit enter. You guys that had the list, you just have to make sure that the first one says L1, the second one says L2, and then arrow down to calculate and hit enter. And we'll all have the same thing on our screen then. And what we're trying to get is this. A formula where they're telling us the A, and boy, wouldn't it be nice if they just used M right here for slope, but they don't. They use AX plus B. You could say B plus AX, but that's, you know, that's still using A as the slope. I think that's because in California and or Texas, the big markets, there's literally 11 times as many people that live there, and that's just California compared to us. So like if you add in California and Texas, it's probably like 20 times as many people live there than here. And we use MX. A lot of states use MX, but they use A in California and Texas and some of the major textbooks. Okay, so A is then given to you. Joe, can you read me what A is? It's a long decimal. Just read me the first few decimal places of it.
14.184.
Let's use 14.18, everybody, for your A. So that goes right here. 14.18x. And then what's the B? Josh, could you please read us what your B is?
71.85.
Can anybody verify they have the same start as him? Okay, good. Now, what the heck is this thing? It's a linear regression equation. What does that mean? Well, if I took the dots on the graph for where these things are, generally taller people have longer fingers, which makes sense. So they generally line up, but the real world is messy. It's not exactly perfectly linear. So what the calculator is doing is it's getting an equation for a line that goes through the middle of those as close as it can. And it's giving us the equation for that line, which is y equals, if I round it, 14.18x plus 71.85. Now the cool part about this is then, if I know that x was the L1 list, which is the finger length, and that is the height, let me show you how you could use that. Imagine for a moment that you're out in your backyard playing with your dog, and you're throwing a ball for him, and you're throwing the ball out in the kind of the woodsy area back behind your house, and he runs and finds it, and he comes back. Well, one time he doesn't bring the ball back, he brings back something else, and he drops it at your feet, and you're like, what the heck is that? And it's a human finger. This is a story ripped out of the headlines. This has actually happened before. And you're like, what would you do? What would be your first thing you'd do, besides scream maybe? Yes?
Obviously, I would try to calculate the height of the person who had
You would obviously calculate the height of the person because you'd look up an equation like this. No, probably not your first move, but you might call the cops. I mean, do you think it would just like throw it in your basement in a Ziploc, you know, just for fun? You should probably tell somebody. In fact, just so you know, it is like illegal to hide evidence of a body. Okay, so yeah, you would want to tell somebody. So you'd call the cops, maybe call I'd call 911. That's a big enough emergency. You'd say, I just found a human finger in my backyard. My dog had it. And then the cops would come out and they would put it in an evidence bag because they wouldn't want to have any more, you know, like fingerprints on it than necessary. And then they would take it and then they would just throw it away and forget about it. No, of course not. They'd take it really seriously, and they would go look up what is the height of the person that had this. That's not the only thing they would do, but that's one of the things they would do. Do you get if it turns out that the finger was 7 centimeters long? It's smaller than all of our data, but we would put the 7 here. Well, how are you going to do that on the calculator? I would clear off your screen. We already have the equation written down. And hit second quit to get out of the weird thing you're in. Second quit will get you out of that, a nice blank screen. And you type in 14.18 times the 7, because that's the finger length, plus 71.85. and you're getting the height. Would you please complete that using your calculator and get the height? Got an answer?
Well, no,
Question.
sorry, question. So wouldn't calculating like trying to figure out the height not be the most accurate like method? Because
Is it super accurate? Not super accurate, but it's gonna be at least mildly accurate.
like on the if you look at the two like lists, two of them have 100.
You're absolutely right. Our data is frustrating because in the real world, you would expect that if you had a person who was 180, what's the one that goes twice? 182 here. Oh, wait. This one, for example, you got two people that are exact same height and they have quite different finger lengths, but that's the real world. You got to do this, and do you think even 10 sets of data would be enough? Now, you'd probably want to get thousands of real-life measurements, and then you put it in, you're going to get really good answers. So right now, you're right, it's off a little bit, but the one that they would look up, it'd be much more accurate than this. This just was real kids in my other hour to just show you that. I mean, I had, and actually in my very first hour, I just faked the data, and it was so obviously not realistic that the next hour I actually had kids come up here and measured their height on this ruler here, and measured their finger length, and this is real world data. Some people, you know, like you would think this kid's taller than this kid, then you'd think that there'd be a difference in the other direction. So anyways, yes, real world's frustrating. So this doesn't give you perfect answers, but it gives you as perfect as you can get. So now we've got our equation, and I hope you have already typed this in, and now I hope you have an answer. Let's go with Camille. What'd you get? Did you already do this or not?
Yeah, I just typed in, so 171.
A little louder. 100 and what?
71.11.
Can anybody verify that? Okay, cool. And your rounding might be slightly different if she rounded different than you, but there we go. That's how tall the person was. Does that make sense? Is it perfect? No, but at least you could know if you find out that there's a person on the missing persons list that's pretty much that height, all of a sudden you might be like, oh, and we thought that they were missing in your area. Now you'd be like, okay, high probability this is our missing person. And then, of course, you're going to go look and see where the dog got the finger from, and is there a chance that that's a burial site or something, or maybe the body's just laying back there. So they definitely do a serious search. And all right, so let's go the other way then. This is our same equation, but I'm not going to put in a finger length. I'm going to give you a height. Let's say, how on earth would we know the height but not the finger length? I'll give you an example. Let's say an alligator grabs a hold of an old person in Florida who's walking around a pond. It happened literally in the same town where my mom and dad were retired people. Could have happened to them. And the alligator just came out and grabbed this old lady, dragged her into the pond. Okay, and so let's say that our lady was 190 tallish, yes, centimeter old lady. And what happened? Well, she's now missing her hand. When alligators grab you, they grab onto, like, if you're lucky, they get your arm, because then you're going to maybe be able to stand up still. And then this is going to get gruesome, so I probably should stop or somebody's going to pass out. But it is possible that you could become separated from your hand. And all of a sudden, this old lady survives it, but now the hand is missing. Well, later, somebody's fishing, and they see something in the water, and they want to see, oh, is there a chance that this is the lady's missing finger? How big should her finger be? Use your formula, and figure it out. How big should the finger be? Pausing for a second. All right. By now, you figured out that you wanted to put that, but not where the finger is. Good Lord. The 190 centimeter long finger, that'd be a very large finger. So clearly it's not that. It must be this. And then you solve for x, and then you'd get the answer. Kate, did you solve it yet? What'd you get? Anybody verify 8.3-ish would be about right? A lot of nodding heads. Good. Okay. So that's called linear regression. And now you know how to do that. And now this is the part that's really important. You're not going to get tested on this until next Tuesday. Do you get that many days will elapse and you'll be like, how the heck do I do that again? I want you to take some critical notes right this second that you can refer back to right before the test. All right, so what was the first thing we did? Put our data where? Stat, edit. And then it goes under, maybe make yourself a little chart thing like this. L1 and L2 is where you put it. And Joe's figured out how to reset if you ever by accident delete your list. That's the first person I've ever had find that. That was cool. It's under stat, and can you remind me?
Yeah, I think it was called like setup editor.
Setup editor or something like that under stat. Yes. All right, cool. And the only way I knew of to fix it is to completely wipe the calculator completely, and sometimes that's not ideal. All right, so anyway, we get our data on the list, and then we hit stat again. Do you remember what we did after that? Calculate. And then under calculate, which one did we pick then? Lin reg. And then a few of you had to, remember the people that walked up here? You had to type L1, L2 if you have one of the old calculators that does it that way. The old operating system makes you type in L1, L2, especially if you're the kid who's not going to have a calculator that day. If you're going to use the same calculator as you just did, and yours is the older operating system, you got to remember that. And then from there, I think you'll remember how to get your equation. Y equals AX plus B, and they tell you A, and then they tell you B. And you put them here and here. Comment or question?
So, on the older calculators, if you just click linear
Yep.
regression and just click enter, you're going to get the same thing instead of typing L1, L2.
Excellent. The only exception to that is if the calculator was used by somebody else previous to you who used L2 and L3, and then it might default to that. See what I mean? So if you just hit lin reg and hit enter, I bet you it'll probably work. I agree. That's kind of like the default. Okay. Are we good? You feel like you know how to do this for the future? All right. This is something we expect you to know how to do. Now, there are some homework problems that would help you practice this, and that's part of what we do today. The other thing is, I'm going to help you get ready for the lab. So here's some advice for the lab. A big day of notes that I would keep for the future, because you know how the lab's going to be doing about a week from now? And many of you are going to be like not worried about the lab until about a week from now. And then you're going to be like, what did he tell us about the lab? This is the day I told you a lot about the lab. So you're going to throw a ball in the air. Would you agree that that makes a parabola that's upside down? But we could be measuring a lot of things here. We could be measuring the temperature of the ball compared to the height of the ball. We could be measuring a lot of things. What do you think is down here? Time is correct. That's usually on the x-axis. It's always the independent variable goes down there. Okay, next thing is, what do you think we are measuring on the y-axis? Height. And then next, who remembers what was marked wrong? By a lot of people had to mark this wrong on the lab because they forgot this. Title. Don't forget to have a title at the top. Okay. Next. This is something in the lab. Think about what it is. It's like how many dogs are on the scene? Of course not. What is that? Yes.
The height that you're throwing from.
The height that you're throwing from. Do you get that when I release the ball, it might be slightly different than when you would release the ball? Maybe you're shorter than me or taller than me. So that is the starting height. But do you remember what we agreed we were going to just pick a simple number for that? 2 meters. And the reason we use meters is because our equation is all going to be in meters. That's important to know. Because our equation starts with a negative 4.9. Can anybody tell me what in the world that is? Yes?
Gravity.
Gravity. That's a number that's based on the gravity here on Earth. The reason it's negative is because it's going to be a parabola that's upside down. Yes?
So is the gravity like it's not
It's kind of like a slope, but does a parabola really have a slope? No. So it's kind of like a slope, but it's x squared, because this is a parabola, right? And then, do you guys know this about the parabola, that the next thing we have is the velocity? Do you even know that? Did anybody ever tell you that? Okay, some of you may have learned it before, but if you didn't know that, that b right there, that's the velocity. Now, do you think you're going to be able to innately know how fast you are throwing that ball up? No. And just to clarify, this is the vertical velocity. Does that matter? Well, technically, we can only measure the verticalness of your throw. If you throw it sideways, it'll still have a vertical component to it, but if you put a lot of strength into the throwing it away from you, that strength could have been redirected into the up. So it's only the up speed. There's technically two speeds, how fast you threw it up and how fast you threw it laterally. We're just measuring the vertical velocity. And last but not least, we put C, but you should know what that is. Would you agree that the y-intercept is where x is 0, and so these two would both be 0, and so that's the y-intercept? In the context of this problem, what does that mean the C is? If it's the y-intercept, it's also what about the ball and everything? Yes?
The height of where you threw it?
Yes. I'd call it starting height. Okay. Now that's just a general equation for this situation. Would you agree that I have taught you two different ways to find the vertex? One of which is completing the square, and I'm going to rule it out. Somebody tell me why complete the square would not be fun. Yes? It'd be really hard to factor out the negative 4.9. Very good. So let's not complete the square. Then what does that leave us with? What's the other way to get vertex? Yes, negative b over 2a, comma, what's the other part of the vertex? If you aren't taking notes right now, you're going to hate yourself later. What? King. Very good. F of negative b over 2a. Now, that begs the question, what's a? I already told you a, didn't I? So what's the only thing you don't know about the vertex? The b. If you could tell me b, then I'd be able to get the vertex. So that's the whole challenge, is you need to figure out b. Well, it's not as simple as just, oh, I see it, b is 6. It's not that easy. It's a lot of work to do, but your challenge really is to figure out b, because we'll have the whole equation if you could just know what b is, because you already know what c is. So we just need to figure out b. So to get b, we need one more equation. Yes?
Is C 20 or 2?
C2 is 2, yes. We need one more equation, though. What's another equation we can do? Yes? That is the velocity, will be meters per second, but that's not an equation. I need an equation. Well, I'm going to give you a hint. This spot here is key. Think about it. What is that? It's not the vertex. It's something important, though. King?
It's the x-intercept.
Yes, and is there a formula for finding that? Yes. Okay, this is the part where I stop helping so much, or if I keep going, I'm just going to end up telling you the answer. So what's your job? Your job is to figure out how high the ball went when you throw it up outside today. Okay? And when the person is taking the video, they don't need to follow it up, because once your camera goes up, you really can't tell how high it is. So their job is to catch the release and to again catch where it touches the ground, because you need that time that the ball is in the air. And that's obviously going to go somewhere in these equations. And you also need, I guess that's the last thing you need. If you know the time, you can figure out b. And if you can figure out b, you can figure out the vertex. And you can figure out the vertex is x, you can figure out the y, which will mean you'll know how high this thing was when you threw it. Okay, so now I know you don't totally get it. That's the point of a lab, is you got to figure it out. but I'm giving you a lot of background, and you need to know what equation goes here, and you need to know your time. So then we're going to get that on video. When you write this up, remember you always have 5 categories. You have purpose. You got to have a purpose in there. And then you got to have a sketch, and that's this thing we just did as part of our sketch, not fully done yet. Then we got to have what's called the procedure, and that's where you say, well, this is what I did to complete the whole lab. First, I threw the ball up, and I made sure to get the starting time and the time then the ball hit the ground, and then I subtracted them to see how long the ball was in the air. That's a good start. And then you say what else you did, and then you just explain what you did. That's procedure. The section called calculation, that's where you actually use these, and you stick numbers in them, and you solve them. Maybe you put an equation inside another equation, but somehow you get your solving B. That's going to be the calculations part, and that's where the real, like, hard math happens. And then the conclusion and reflection is just like, yay, I found my equation, and here it is, and this is how high I threw the ball. That's your conclusion. And then you reflect on it, and then you say, this is what I learned from this. I thought it was actually interesting that blah, blah, blah. This is how we could make the lab better. Okay. All right. So what are we going to do tomorrow? Tomorrow is going to be a work day where you get to work on the lab. You get to ask me questions about the lab. I won't tell you answers, but I mean, I might give you hints and move you towards the right answer in the lab. And then you'll actually do a few regression questions for practice. I'll remind you where they are then. And then that's unusual. We don't normally have work days, but I did so much today. We might have one more thing to grade tomorrow because we may not have time to grade it in class today, along with throwing the ball up in the air. Okay, any other clarifying questions about the lab stuff? Nicole?
Why is the gravity 4.9 and not 9.8?
Because it's divided by 2. Gravitational constant, when you put it in this equation, why is this the velocity? It is the velocity. Why is this gravitational constant, why did it have to be split in 2? Because it's a part of the big general equation, and it's always 1/2 of the gravitational constant, and then this is usually used t squared, and this is just how you set up this equation. Vt plus initial velocity, or no, initial height, so then you go h sub 0. This is just the format of the quadratic that we are using, and it's 1/2 of the gravitational constant. Okay, yes?
Is there a specific form that you want us to use for the lab, or just like a blank document?
A blank, I have given you one in the lab folder that I call complete. That means it's got like the little reminder of all the sections, you know, like the purpose and the sketch and all that stuff. It's got a reminder of that, and it's got room to work right in that document. So find the one in the labs folder. Any other quick clarifying questions? Yes? No, there's multiple right ways to do it, but that's the reason we have those categories. You always have to have a purpose. You always have to have a sketch. You always have to show me how you did it. You always have to explain in words how you did it. That's the procedure. And then you always have to have your conclusion where you say your answer. And then there's the last thing is the reflections, where you have to have 3 reflections where you reflect on what you learned. So if you use those categories, there's a lot of different ways you could do it. But from my experience, there's one key moment and one key equation that I haven't even written down yet, that you have to like realize, oh, I can put in this and this into this equation, and then I can solve. That's usually what happens. But there's more than one way to do it. Anna? This is in the summative category, yes. All right. Now, we've done enough that tomorrow we can just have a work day. Maybe we'll grade something tomorrow too, like that old 10-step thing. But that's it for the video for today. We're going to go out and throw the tennis balls in the air. If you're at home doing this, just make sure you get it on your iPad. Make sure the person taking the video sees where you release the ball and sees the moment the ball hits the ground.